Hello students, still we are moving forward and I am here to give you some highlights of lesson 3. And today we will see the actual concept of uniform motion and some features of distance, displacement, speed and velocity of a moving body. And as usual, I will encourage you to keep your attention until the end of this video. Thank you. When an object travels in a straight line and covers the same distance at the same time, it is said that the object is in uniform motion. Uniform motion is described in physics as motion in which the speed of a body traveling in a straight line remains constant. A uniform motion occurs when the distance traveled by a moving object is the same at multiple time intervals, regardless of time length. Look at the given motion picture. Remember, the term uniform means the same or constant. That means the physical quantity which remains constant in uniform motion is speed. And when we say a body moves in a constant speed, mean that it covers equal distance in equal intervals of time. The following are some examples of uniform motion. The first one is the clock's hour hand operates at a constant speed, covering a certain distance in an hour. And second one is an airplane traveling at a constant speed at altitude. And the third one is a car traveling at a constant speed along a straight flat road. And the fourth one is a train moving at a steady pace along the tracks. Generally, uniform motion occurs when an object moves at a constant speed in a specific direction at regular. And the other point that we need to discuss by today's discussion is about distance and displacement. And let us start from the concept of distance. Distance. We must be careful when using the word distance since there are two ways in which the term distance is used in physics. We can talk about the distance between 2 points, or we can talk about the distance traveled by an object. Distance is defined to be the magnitude or size of displacement between two positions. Note that the distance between two positions is not the same as the distance traveled between them. Distance traveled is the total length of the path traveled between two positions. Distance is the total amount the object has traveled in a certain period of time. Distance traveled is not a vector. It has no direction and thus no negative sign. For example, the distance the teacher walks is 2 meters. The distance the airplane passenger walks is 4 meters. It is important to note that the distance traveled does not have to equal the magnitude of the displacement. Specifically, if an object changes direction in its journey, the total distance traveled will be greater than the magnitude of the displacement between these 2 points. Displacement. If an object moves relative to a reference frame, for example, if a teacher moves to the right relative to a whiteboard, or a passenger moves towards the rear of an airplane, then the person's position changes. This change in position is known as displacement. The word displacement implies that an object has moved, or a person has moved, or has been displaced. Displacement is the difference in the object's position from one time to another. And displacement is a vector. That means it has a direction as well as a magnitude. And it is represented visually as an arrow that points from the initial position to the final position. Consider the following situation. If the body changes its position from point A to point B, then the solid line represents its distance, while the one drawn by the dotted line is its displacement. Generally, let us look at the main difference between distance and displacement. The first difference between distance and displacement is distance is the total or complete path traveled by an object, while displacement is the shortest distance between the final position and the initial position of the motion of the object. And second difference is distance can never be negative, it is always positive, while displacement can be positive, negative or zero depending on the context. And the third difference between distance and displacement is distance is a scalar quantity, while displacement is a vector quantity. Students, we'll learn more about scalar quantity and vector quantity in the next chapter. And the other difference between distance and displacement is distance does not decrease with time, while displacement can increase or decrease with time. And remember, distance is never less than the displacement value, while displacement is either equal to or less than distance. And distance is denoted by capital letter S, while displacement is usually denoted by capital letter S and an arrow on its head to show it's a vector quantity. And the other difference between distance and displacement is distance gives the complete information about the path traveled by the object, while displacement does not give the complete information about the path traveled by the given object. Speed and average speed. Look at the position time graph of a bus moving on a straight road. The above graph showing the position of a moving bus at different instants of time with respect to the point x is equal to 0, which is the origin. Suppose you want to know how fast is the bus moving. You can find the answer to this question by calculating the distance traveled by the bus in 1 second or in 1 hour. Try doing so. You know the word speed very well as you use it in your daily life. You know that the speed of an airplane is much more than the speed of a train. The speed of a bus is much more than the speed of a cyclist. A fast-moving object has high speed. A slow-moving object has low speed. In the figure above, the bus moves 80 meters in 8 seconds, so it moves 10 meters in 1 second or 36 kilometers in 1 hour. This brings us to the concept of average speed. Speed of an object is defined as the distance traveled by it in unit time. That is, speed is equal to distance over time, or V is equal to S over T. And the average speed is defined as the total distance traveled divided by the total time it takes to travel that distance. That is, average speed is equal to total distance traveled divided by total time taken. That is, VAV is equal to S total over T total. Students, remember, the SI unit of speed and average speed is the same, which is meter per second. Since distance is measured in meter and the SI unit of time is second. And the other point is instantaneous speed. To calculate the instantaneous speed, we need to consider a very short time interval, one that approaches 0. For example, a school bus undergoes changes in speed. Or instantaneous speed is the speed of a moving body at a particular instant of time. And mathematically, the instantaneous speed of a body is expressed as V instantaneous is equal to the limit of change in distance over change in time as change in time goes to or approaches to 0. Velocity and average velocity. Velocity is displacement of the moving body divided by the time taken. That is, velocity is equal to displacement divided by time taken. In symbol, we can express it as V is equal to S over T. And since displacement is measured in meter and time is measured in second, therefore the SI unit of velocity is meter per second. And remember, velocity is a vector quantity. The average velocity of a body is the total displacement covered by that body in a specified direction divided by the total time taken to cover the displacement. Students, here we have two approaches that we can use to describe the average velocity of a body. The first one is average velocity is equal to the change in position divided by the change in time interval. Or in symbol, VAV is equal to change in S over change in T, which is equal to S final minus S initial over T final minus T initial, where SF is the final position at final time TF and SI is the initial position at time TI. And this equation is important for one-dimensional movement of a body. And the second approach that we use to define the term average velocity is, here it is, VAV is equal to total displacement over total time. That means S total over T total, and which is important for two-dimensional motion. The average velocity can be positive or negative depending upon the sign of the displacement. The SI unit of average velocity is meter per second. Unlike average speed, average velocity involves only the displacement of the object. Now think of this situation. Suppose you are traveling in a train. Do you always move at the same speed or with the same velocity? The train stops at different stations. Sometimes it moves fast and at other times it slows down. So its speed and velocity change at every instant of time. The average velocity does not tell us how fast an object moves at any given instant. To describe this kind of motion, we can use words like instantaneous velocity. Instantaneous velocity. Instantaneous velocity is a vector representing the rate of change of position with respect to time at a particular instant in time. A practical definition is that the instantaneous velocity is the slope of the position versus time graph at a particular instant. Mathematically, we can express instantaneous velocity as V instantaneous is equal to the limit of change in S over change in T as change in T goes to or approaches to zero. Generally, students, there are two important points to remember. The first one is speed is a scalar quantity and has magnitude only. However, velocity is a vector quantity and has magnitude as well as direction. And second one is speed tells us how fast a body is moving, but velocity tells us how fast and in which direction the body is moving. Students, this is all about what the today's lesson looks like. So how do you get it? Do you like it? That's my pleasure. As usual, you can share this video for your friends, classmates and others, and you can invite others to follow and subscribe this channel. Remember, in the next video, we'll solve some selected interesting problems about what we have seen today. Thank you for watching. See you next time.